Hello subscribers and viewers, what's up? My name is Larry. In this video we are going to be talking about how we can write a Timelock contract. So what the contract basically does is it enables users to deposit some amount of it into the Timelock contract. So they also set a timestamp, which means within the starting time and the closing time they won't be able to have access to the money they lock. So they will have access to it before the starting time or after the closing time. So now this function also allows users to store to a contract, and withdraw allows users to withdraw from the time log. So we also write tests to make sure that the functionality of our functions, like every functions of the contract, works as we expect them to work. So the framework we used for this project is hardhat. So now I'll be building this Timelock contract from scratch, and I'll make sure you guys understand every line of code I write. So now let's get started. Alright guys, so since we are building this project from scratch, so let me create another folder for the project. So let me go to my Visual Studio Code projects. So this is where I normally store all my projects. This particular folder, Visual Studio Code projects. So this is where I store my project. So let me create another folder inside our directory. So let me call it Timelock. So now the directory has been created. So let me see the inside this directory. So now we see Timelock. Right. So okay, now the next thing I want to do is I want to install hardhat inside this folder. So I'll write this. I'll type this yarn add -- dev hardhat. So then when I click on enter, so I'll need to wait for a couple of seconds for it to install hardhat. Alright guys, so hardhat has successfully been installed in this Timelock project. So the next thing I have to do is, so I want to create a sample project of our hardhat. So then I type this nps hardhat. Okay. Right guys, so now let's click on this create a basic sample project. So click on enter. So you can move it up and you can also move it down, but I prefer to create a basic sample project. So let's click on enter again. So do you want to add a git ignore file? Yeah, let's click on yes. Why? So now the project has been created. Now the next thing I have to do is, so I want to go to my Timelock. I want to open the Visual Studio Code, this particular folder. So code dots. If this command doesn't work on your system, you can open it manually. So let's click on enter. So that's opened, right? So now this is the sample project that has been created for me. It has a contract folder, a script folder, a test folder. So if I check the contracts, we are already given a sample smart contract file. So all this we don't need it, so we have to delete this data. So scripts, the test, and we also have the hardhat.config.js. So we need to install some dependencies. Get started. So now let's open up our terminal. Yeah, so now let's type in this and add. Let me paste this and delete this. So we need to install all these dependencies. So yarn add, yeah, -- dev. Now I personally prefer using yarn. So you can use npm if you like, but I just prefer using yarn. So let me click on enter. So I have to wait for a few seconds to install all these dependencies in my project. Alright guys, so the dependencies has been installed successfully. So yeah, everything has been installed, right? Okay, now let's close the terminal. Alright, so the next thing we have to do now is we need to create a Solidity file. So let me right click on the contracts, click on new file. So let's call it timelog.so, right? So now this is my Solidity file. So before deleting this greater.so file, I just need to copy these two lines. Let me copy it and paste it to the other file. All right. So now let me just delete this greater.so. Now I don't need that. Move to recycle bin. So contract timelog, right? Now we need the store function to store to allow users to store money to our Timelock contract. We need the withdraw function. So let me just start here. So now what we want to do now is we want to define a function that allows users to store some amount of any amount inside the Timelock contract. So we have store. So this allows users to store some it inside the Timelock contract. So we need to define another function withdraw. So what this function does is it allows users to withdraw when they store any amount inside the contract. So without this withdraw function, the money will be locked forever. So we need to define that function. Let me just quickly type what it does. Right, guys. So now after the withdraw function, we also need the set timestamp function. And this set timestamp function. So what the purpose of that function is, it allows users to specify when they want to lock their amount, when they want to lock their money in the contract. So they specify the opening time and also the closing time. So which means within the opening and the closing time, they won't have access to the money they lock. So let me just write a note on what the function will do. This gives users the power to specify the amount, the time, the opening and the closing time of the time log. Okay, guys, so now we know what we are about to do. So let's start by creating the set timestamp function. Now this set timestamp function is taking in two arguments. So let me just, to define a function in Solidity, we use the keyword function followed by the name of the function. So let's call this function set timestamp. So we are expecting two arguments whenever the user calls this set timestamp function. So the first argument should be the starting time, and it should be an unsigned integer, starting time, and the other argument should be the closing time. All right. So this uint is an unsigned integer, which means any integer from 0, any integer that's greater than 0. So this unsigned integer can be a negative number. So start time cannot be a negative number. It can only be a positive number. So which means it can start from 0 to infinity. Also, this actually it's not infinity because uint itself is 256. So that's limits. Instead of, we can either use 256 or just uint. They are the same. So the same thing is applicable to closing time, uint. Yeah. So the next thing is to specify how our set timestamp function will be visible. Now if I use public, so this public means I want my set timestamp to be available anywhere in my smart contract, and also it should be allowed to be called outside of the smart contract. Which means maybe when we are working with our front end, you can call this set timestamp function if it's public. So we can also use external. So this external, the difference between public and external is if a function is public, if a function is external, it won't be it cannot be used within the smart contract. So we can only call it outside of the smart contract. So other functions of this time lock contract won't have access to this particular system stamp function because of its visibility external. So that's the difference. So since we are not calling our function this time stamp function inside our smart contract, so let's just leave it as an external function, right? So external, right? So the next thing we want to do is okay, so we want the user to be able to set the certain time and close time only once, which means if user has set already, he or she won't be able to set it again. The user only has one chance of setting his starting time and the closing time. So now I need a variable that will keep track of starting time and the closing time of every users. So when a user comes to use our smart contract and sets his start time and the closing time, so I need a variable that will store the details for every users. So I wanted to create a struct. Let's call it user. Takes in two variables. The first one will be starting time, and the other one will be closing time. Okay. Now what this the meaning of this struct is, it allows us to create our own data type. Yeah. So it is a way we can combine different variables together. Then if we want to access one of the variables, we can use an instance of this user struct we created, right? So instead of using a variable to working with only a variable, we can use a struct. So the struct will have many members, many variables inside it, so we can access any of the variables inside it with this struct instance we create. So that's struct. Okay, right. So now, so we want to check the starting time and close time of any user that calls this send timestamp function, and we want to make sure that user can only call this function once. So how are we going to do this? Well, let me create a mapping that maps the address of a user with um its structs. So this is what I mean. Mapping address with user. So this struct is just like a data type, normal data type. So this is the way we create data type in Solidity. So let's call it users. So I'm trying to map the address of user to his struct, to a struct. So now to check the first time and close time of any user, you can access this user struct like this: users address. So this code here will return the user struct. So I can create a variable that will hold the user struct. So storage user. So let's leave it like this. Right. Now the meaning of this, I mean msg.sender. The msg.sender is the current user that is calling our timestamp function. Oh, okay, it's bringing out 0 because I haven't used the starting time and the close time, but we are still going to use it. Okay, now msg.sender is the current user that is calling our function. So msg.sender will return the address of that current user. Okay, now storage means when we use storage on any variable, it means you are trying to access one of the users that is already stored in our in the blockchain. So it's return a user that is already stored. So that's what we want. So we want one of these users to be returned. One of these users in this variable. So that's what we want. So we want to access one of the already stored users. So that's why I used storage. Memory. So when we use memory, we're not trying to access any stored user. When we use memory, we are just trying to create a variable to use just within the function, within the execution of the function. So we can use memory if we really want a function that will, a variable that would be persistent within the execution of the function. So that's when we use memory. But storage is, we want to access a variable that's already stored in the blockchain. So that's why I used storage here. So user storage user is equals to users msg.sender. So now, since I've created an instance of this struct, now I can access the starting time and the closing time of this current user. So now to access that starting time, we use user dot operator starting time. So this will return the starting time of this user that is trying to call our timestamp function. So okay, now require. So what I want to do here is I want to make sure that this set time and closing time can only be called once by every user. So when you code this, when you set your timestamp, you'll be able to set it again. So you only have one chance of setting your timestamp. So require that this user does starting time is equals to 0. Starting time is equals to 0, and user dot closing time equals to 0. Alright, so now require user dot starting time is equals to 0. So this will return the starting time the user stores. If the user has stored it already, so it return what the user stored previously initially. So now we're trying to compare if it's equals to 0. Now, if it's equals to 0, it means that the user hasn't set his time yet. Hasn't set his starting time, and also if it is equals to, if the closing time is equals to 0, this user, this current MSG, the sender, hasn't set his closing time. So if this condition is false, so we want this to be the message. So let's say time has already been set. Time has already been set. So now require. Okay. Now this require function takes into arguments a condition and a message. Now if this condition is evaluated and it results to true, the code will continue getting executed. So yeah, the code will continue getting executed. But if this condition results to false, this transaction will revert. Right? That's the purpose of using require. So require user dot starting time is equal to 0 and user dot closing time is equal to 0. Time has already been set. But if time hasn't been set, so now let's set it. So user dot starting time is equals to okay, let me now let me just store the start time and close time of this user to our variable here. Okay, so that would be users of msp.sender is equals to user starting time and closing time. Yeah, right. So now when this user sets call this set timestamp function, the function will check if the start time and time has been set. It has been set before. If it hasn't been set before, then we set it ourselves. Set it for the user. So that's what this line does. It creates an instance of the struct user passing the variable, passing a value for these two variables, start time and close time. Then we store it with this ms, we store it inside this variable, this users variable, this mapping. So we are mapping msg.sender, this address. So this represents this address with the user data type. So that's it. Users msg.sender is equals to this, right? So now after this, so I would like to print out the starting time and the closing time of the user whenever this function gets executed. Like, I would like to print it out to the console, something like that. But in Solidity, we can't use console.log or print or whatever. We can't use this in Solidity. The only way we can print Solidity is if we emit an event. So if we want to emit an event, we have to create an event first. So let's say event timestamp set. So now before we can print something to the console, we have to create the event first. So the event will take in what we want to print out. Since we want to print out the starting time and the closing time, so I have to pass two parameters here. So the first parameter will be the starting time and the other parameter will be the closing time, because I'm just trying to print onto these two values. So now starting time and closing time. Okay. Now after creating the event, so I can now emit the event here. Emit time stamp set. So now I can now pass starting time, then the closing time. Right, okay. Now when this code gets here, as the code execution gets here, it will see that we are trying to emit an event. Then this timestamp, this start time and close time will be printed to the log, to the blockchain log. So we're able to have access to it, maybe in the front end or whatever. So this is it will be print in Solidity, right? So okay, guys, since we are done with our system stamp function, so let's move on to the store function. So now function, the name of the function, store. So here we are not expecting any arguments here. So store, we want our function to be public. So the scope of the function should be outside of the smart contract, or I mean, it can be called as outside of the smart contract or within the smart contract. So that's why I want it to be public. I just want to use public here. We can even use external because I didn't call this function inside smart contract. So okay, let me just use external. So now this function, now when the user calls this function, we are expecting the user to send some amount of money whenever they call this function, because that's the purpose of this function. This function allows users to store their money inside this time lock. So we're expecting the user to send some money whenever they call this function. So now for this function to be able to accept any money, user sends, we need to make it a payable function. It is payable. We need to make this function a payable function if we want this function to accept money. Now this payable allows the function to send the money to the contract, to the Timelock contract itself. So now that's the usage of this payable keyword. Okay. So now the next thing is let me just open braces. The function store external payable. Okay. Right. So now what we want to do here is we want to make sure that what's happening expected expire. Okay. Now we have to make sure. Oh, I'm creating my function inside this set timestamp function. That's why it is bringing out the error. So let me just delete let me move it up. So let me paste it here. Okay. Okay. Now this step function, I want to make sure that the amount user sent is greater than 0. So require that msg.value is greater than 0. So msg.value is the money the user, this current user sends to the user that is calling this step function. So msg.value will return the money, the amount in WEI, WEI, the user sends. Now if the user sends like 2 ether, I'm sorry, I'm trying to comment. So 2 ether. So msg.value will return 2 times 10 to the 18th power. So that's what will be returned, because it has 18 decimals. So 10 times to the power of 18. So this is what will be returned by msg.value instead of our normal 2. So msg.value will return this value 2 times 10 to the 18th power. So we are requiring that msg.value is greater than 0. So now if it is not greater than 0, let's display this message. Let's say let's just say amount should be greater than 0. Amount should be greater than 0. Okay. Now, okay, so now after this, we have to make sure that whenever the user sends some amount, we need to be keeping track of the balance of the user in the Timelock contract. So when the user sends amount, we need to create let's say maybe a mapping that maps the user with his current balance. So something like that, like a mapping that maps this particular user that's calling this store function with his current balance in our Timelock contract. So let's create that mapping here. So mapping, let's map the address of the user with his current balance uint, or to uint with cell to see they are the same. So let's call this balance. Let me make this function public, because I want to be able to have access to this mapping outside of the smart contract. So that's why I make it public. So balance. Okay. So now this mapping will be the one that will map the address with balance of the user. So now let me update the balance whenever the user tries to store some amount in our Timelock. So balance of msg.sender is equals to balance msg.sender sender plus msg.value. So what we are doing here is we are trying to fetch the balance of this user, then adding the amount the user sends to it, then replacing the balance with this new balance. So that's what we are doing here. Replace the amounts with these new amounts. So that's what we are just trying to do here. So now the next thing we have to do is, I think that's all for this store function. Require, we want to make sure that the value user says is greater than 0, and we are updating our balance mapping. So alright guys, now let's work on the withdraw function, So function withdraw. Okay, now we are expecting an argument. We are expecting the user to pass in an argument here. So that argument will be the amount the user wants to withdraw. So unit amount. So function. So let me just use public for this public. Okay. Now, so we have to get the start. Okay, what we want to do here is we want to make sure that user can only withdraw before the starting time, and after the closing time. So that means within this duration, within the starting time and the closing time, we don't want the users to have access to the money they blocked. So we don't want them to be able to withdraw from our time lock. So now, so let's get the start time and the close time of this current user as trying to call our, that is calling this function. So let's get the start time and close time of that user. So to get that, I can get it from this mapping here. So user storage user is equals to users msg.sender. So users msg.sender will return this this particular user. Yeah, so it will give us the user struct. So then I created a variable that will hold that user struct, and I make it storage because I'm just trying to fetch from what's already been stored in the user's mapping. So that's why I make it storage. It has already been stored. So now require that the current time block dot timestamp. The current time is before the starting time. So we can use is lesser than user dot starting time. And also the current time, like the time right now, block dot timestamp. The current time now is greater than the close time, is after the closing time. So user dot closing time. So block dot timestamp returns the current time. In Solidity, you can't keep track of the time. We use block to determine our current time. We use the blocks to determine the current time. So require that the block dot timestamp is lesser than user's time. So that is before starting time, and require that block dot timestamp is greater than close time. So that's after the closing time. Otherwise, so let's just use this message. Contract still locked. Can't withdraw. Can't withdraw. Okay. So okay, now the next thing we have to do is so we have to make sure that the money the user is trying to withdraw is lesser than or equals to its balance in the time lock. Its balance here. So the money the user is trying to withdraw is lesser than or equals to its balance. So require that the amount is lesser than or equals to its balance. So how will I get the balance of this user that is currently calling our withdraw function? So I can get balance from this mapping. So balance of this address will give me the current balance. So balance of msg.sender. So now this will give me the current balance of the user calling our function. So require that the amount the user is trying to withdraw is lesser than or equals to its balance in the Timelock contract. Otherwise, let's just use the message amount should be lesser, or you don't have up to that amount. You don't have up to that amount. In the time log. Right, so I require that amount is less than or is equals to. So this reverts if the execution gets here and this condition is just to false, the execution will stop and it will revert. So this will be the error, the error message if this reverts. So that's the purpose of the message. So require that amount is equals to balance. Then after doing this, so the next thing we want to do is we want to transfer this amount. If the execution gets here, so it means that the amount is greater than the amount is lesser than or equals to is balance in the time log, and we are not within the starting time and closing time. So now what I want to do is I want to transfer the money to the current caller of this withdraw function. So now to do that, msg.sender.transfer amount. Okay, now this msg.sender. So if you want our msg.sender to be able to be paid, we have to make it a payable address. We have to make it a payable address. So only a payable address can receive or send money, right? So only a payable address can receive or send money. Okay. Now, transfer function is a function that can be called on an address, and the transfer function takes in an amount. So this amount will be transferred to this msg.sender. So that's what the transfer function does. It transfers this amount to msg.sender. So that's what we want. We want to transfer this amount to msg.sender when these two conditions are not reverted. So that's what we want here. So okay. So now the next thing we have to do is we have to update the balance of the user in the time lock. So that's what we want to do next. So now to do that, you can just get the balance of the user, balance msg.sender. So this will give me the balance of this msg.sender. Then so let me subtract this balance from the amount. So balance msg.sender minus amount will now be the new balance of this msg.sender. So this balance will be updated immediately this transfer function has been completed as successful. So the balance mapping will be updated with the new balance. So and that's all with the withdraw function. So we are done with our store function, the withdraw function, and the set timestamp function. Okay. Now imagine if this withdraw function is called recursively, very fast, by this same msg.sender when balance that is keeping track of the balance of the user is not yet updated due to some issues of the blockchain or whatever. Now imagine if there is recursive call to this withdraw function. It might lead to loss of funds because this balance might need to be updated. So now to prevent this, now that kind of attack is what we call reentrancy attack. Reentrancy attack, because we're trying to call this function recursively when this balance is not yet updated or something. So now to prevent this type of attack to happen, so we can use a modifier that prevent this thing from happening. So now OpenZeppelin has a library that gives us that kind of modifier that will make us secure this withdraw function. So now let's grab that from OpenZeppelin. So now to do that, I will need to install the OpenZeppelin contracts. So now let's install OpenZeppelin. So let's install it. So yarn add OpenZeppelin /contracts. So let's click on enter. So it take my system a few minutes to download it. So I'll just pause it and I'll resume when it's done downloading. So right guys, so my system is done installing OpenZeppelin contracts. Now, so you can check it here. The node modules. OpenZeppelin. That's open. I think it's not yet displaying here, boss. Okay. Now we need the entrance guard from the OpenZeppelin library. So I will need to import it first. So import slash open zeppelin slash contracts slash creating reentrance guard. That's all right. So we can check the contracts here. So this is the reentrance guard from Open Zeppelin. So this is the contract we need. So now to make use of this contract, we need to inherit all these functions and all these attributes from. We need to inherit it. So to inherit this reentrance guard, so I need to use this is keyword, then the name of the contract, reentrance guard. So now when we do this, so what we are doing is just like we are copying all the codes here inside the contract, inside the Timelock contract, all the codes here. The codes here, then pasting it here. So that is what is happening under the hood. So that's what we are doing whenever we use this is reentrance guard. So it's just like we are copying all the codes from the reentrance guard smart contract to our smart contract. So that's what is happening. So that means we now have access to all these modifiers, non-reentrant, and all these constants. So let me just delete this. Let me delete this. Okay. Now, because I don't want reentrance attack to occur with this without function, so I'll need to use a modifier from reentrance guard. So non-reentrant is the identifier I want to use. So this identifier will prevent this function to be called recursively when this balance is not yet updated. So the next call will wait till this balance is updated before the next call is executed. So that's because of this non-reentrant. So to prevent reentrance attack, so that's the purpose of non-reentrant, and we inherit this non-reentrant from the reentrance guard just to smart contract of the Open Zeppelin library. So that's it. So I also want to use non-reentrant here. Non-reentrant. So yeah. And I think that's all. Yeah, I think we are done with our smart contracts. So now let's compile it. So let's open our terminal, control splash, then npx add compile. npx add compile. So let's click on enter. So let's wait for a couple of seconds for the smart contract to compile. My system is a little bit slow. Oh, all right, that was compiled now. So compile to Solidity files successfully. So let's check our file explorer now. An artifacts folder has been generated. So we have the Open Zeppelin build info contracts, right? So now, so the next thing we have to do is we have to make sure that we test our contract, so that we'll be very sure that all these functionalities are working as we expect. These functions are working as we expect them to work. So we need to write a test. Now let me create a test file here. Let's call it timelock test.js. So I don't really need this sample test.js. So let me just delete it. So delete. All right. So now we need to import from the child dependency. So I want to import the experts and child itself from, let's use child. So yeah, it's importing expert and child from this child dependency. So I also want to import const ethers is equals to require, and so I'm importing ethers from the require this and that dependency. Now to check if all these dependencies has been installed, you can go to the package.json file. You get to see it here. So this is the hardhat dependency, and this is the child dependency. So let's go back to our Timelock contract. The test. All right. Now, so to start writing our test, let's group the test together with describe with this describe function. So this describe function takes in two arguments, and the first argument is the name of the group. So let me just call it Timelock, and it takes in a second argument which is a function. So for now, let me just make it normal function. Okay. So now the next thing is, since I said it groups tests together, so let's check. So let me tell you what I mean by that. So this is a test. We create a test with this it function. So this it function takes in what the test will do, like summary of the test. So let's just say should do. Okay, let me just use it as an example now, and it takes in a function. So the function is where we're going to write the code to test, to check, to do what we want to do. So this is a test. So let's just create another test again. Let's call 3 tests. So let me use B here, and let me use C here. Now if I run these tests, npx hardhat test. So now if I run this, so it is running. Okay, now it has compiled, it has run. Now you will notice that these 3 tests are grouped inside. Now this Timelock is like the title of these three tests. So that's the purpose of using describe. Describe allows us to group tests together. So I can also, okay, let me just copy and paste this describe. This every time I do this, let me copy and paste it again. So let me highlight and then copy. Now let me run the test again. So now let's call this Timelock 2 as an example. Timelock 2. So let me run instead of C, let's call this maybe D, and let's call this E, then this F as an example. All right, instead of using Timelock, let me just do something like first 3 letters on this first second group. Let me just use second group as an example. So if I run this, if I run the test, add test, now you can see how it is grouped. These 3 tests are grouped inside this describe argument. It is this name, and the other group is inside this describe name, the first argument of the describe function. So that's the purpose of describe and needs. All right, so now let's delete this. Let me close the terminal. Let me delete this. We don't need this. Okay, now we also have the before function. Before. Now this before also takes into arguments. The first argument, one argument, and the argument is a function. Okay. Now let's say I want to print let's just use inside before here, inside before function. Okay, so now if I display this, if I run this test, we're going to notice that this line will run once, then each test will be executed immediately after the code inside this before function is executed. So now if I run this, let me just clear my terminal. npx hardhat test. Okay. Now we can see that the this code consider log said before is executed. Then after the execution of this function inside this before argument, each test is now executed immediately after it. So that's the purpose of before function. It gets executed once, then the test gets executed after execution of the before function. So that's the purpose of before. We also have before each. Before each. Now instead of executing once, it executes during the execution of each test. So which means this particular line will be executed 3 times because we have 3 tests. So that's it. To be executed 3 times before we have 3 tests. So let me just print out some. Let's just say a. Let me copy this line. So let me paste it here. So now instead of A, let me use B. And here, let me use C. ABC. Okay. Now what we are expecting is this because this consider log is inside the before each function. So inside before will be displayed, then followed by A. So in the next test, this inside before will be displayed on the console, then followed by B. So the same thing will happen to this last test. So which means inside before is executed during the execution of every test in the describe that is grouped together with this describe function. So now let me just run this so that you understand better. npx add test. Okay, it is executing. The test is running. Okay, all right. So now it has run. So now that's what we are expecting. Okay, let me start from here. Okay. Now before each, the code inside this before each gets executed 3 times because we have 3 tests. So now in the first test, this test like this, we print console.log E. So we are displaying A. So that's the A. And this inside before will be executed before the code in the block in the test actually is displayed, is run, is executed. So that's why we have inside before this A. So the same thing will happen here. The inside before is displayed first, then followed by B. So and the last test inside before will be displayed first before the actual content of the test. So now that's because of before each function. It gets executed. The execution is dependent on the amount of tests we have in the group. This is described. So that's the purpose of this before each. So now let's continue. Now let me delete. So now I don't need before each. I only need before. I need before for what we are doing for the test we are trying to write. So let me delete all these tests. I think I don't need. Okay. So now I want this function to be asynchronous because I want to use the await keyword within the function as async. Okay. All right. Now what I want to do here is I want to deploy our Timelock contracts. This Timelock contract, I want to deploy it. So now to deploy this, so I'll need to get an abstraction of the Timelock contract. Timelock is equals to await it has get contract battery. So this function takes in the name of the contract we are trying to deploy. So the name of this contract is Timelock. So that's the name of the contract. So that's the name I'll pass to this that's the name I'll pass here. Timelog. And this get contract factory returns an abstraction. So that abstraction is what we're going to call the deploy method on. Now actually start sheet and instance of the class of the contract. So timelog dot deploy. So you have to use the await keyword for deploying. So it waits for 15 minutes. All right. So now during this stage, we are trying to deploy our contract. Now after this line, we can now have access to the address of this Timelock contract. So let me hold it with a variable. Let's use Timelock because I'll wait to deploy. So now I can check the address of the Timelock contract. Timelock.deployed. I mean Timelock.address. For this Timelock. Now if I print this out, if I run the test, let me just npx hardhat test. If I run this, we didn't have the address of the test, right? Okay, I think I need to put await. Then I have to create a test before this line can display. So let me just create a test function. I don't need to put up anything. So now if I run it, it should display now and at test. All right, yeah. So that's the address of the Timelock contracts. Okay. Now, so the next thing we want to do is we want to deploy. At this point, we are not 100% sure that our Timelock contract has been deployed. So now we need to call the deployed function on this Timelock instance to make sure that our contract has been deployed. Yeah. So now after this line, you can now make use of this Timelock instance to call the functions of this Timelock contract. Okay. So now the first thing we want to test is we want to check if the timestamp will be set correctly. So let me call this test. It should set closing time and the ending time. So I want this function to be asynchronous. We have to specify the starting time and the closing time before we can call this set timestamp function of this smart contract. So now how are we going to create our starting time and the closing time? So now let's say we want our starting time to be. So let me just close the terminal and this. So now we want our starting time to be a day from now. So that's a day from now. So that's what, yeah, and we want our closing time to be 3 days after the starting time. 3 days after the starting time. So that's the time we want to set. So we want our starting to be a day from now and this time to be 3 days after the starting time. And we know that Solidity works with seconds. So we have to make sure that the time we pass to the contract is in seconds. So now const starting time is equals to maybe a now plus a day. Let me do something now. Current time now plus a day. in seconds. So this is what I want to achieve. So now to get to make this, to create the function, to write the functionality of this comment. So let me create another folder. So let me call it the utis this folder. So let me create a new file. So let's call it duration.js, and another file, current time .js. So let's work on the current time. So what we want this function to do is to return the current time. So now let's define the function async. We want the function to be asynchronous. So function current time. So now, so what we want to do is we want to get the most recently mined block in the hardhat blockchain, in the local blockchain. So we want to get the most recently mined block. So now to get the most recently mined block, so we need to get the block number first. So block number is equals to await ethers dot provider dot get block number. Okay. Now this get block number returns the latest block. So now to get the block from that block number, to get the actual block, so from that block is where we are going to obtain the timestamp with other properties. So now to get that particular block, so we use await as does provider dot get block. Now we pass the block number as an argument. Okay. Now this get block returns an object with a lot of properties. Where one of the properties is timestamp. So this timestamp is what we actually determine the current time of the the current time. So I can return timestamp. Yeah. Now, for us to be able to use this current time outside of this function, I want to export it. So module.export equals to current time. All right. So now this timestamp returns second. It returns the second from 1960 or from the epoch time, something like that. So that's what this timestamp returns. So this is what we are going to use to get our current time. Now let's go back to the test. Timelock test. So now I need to import this duration. I mean this current time from. I need to import it in our test. So const. Let me just call it now. Yeah, let me call it now. It's supposed to require duration. What am I calling duration? Require current time, because that's what we exported. This is function. So require current time. Current time. But let me use current time instead of now. Let's just use current time. Since it's a function, so require current from this utis folder. Since I'm importing, I have to specify the part. utis/current time. Yeah. Now this current time is a function returned. Yeah, this current, we are trying to return this current time, so we can call the function inside our test here. So so let me just create a variable. Let me call it now. It's equals to await current time. So this current time will return the current time in second. So we can now use it here now. So this is actually the current time, the time right now. So since I want my start time to be a day from now, so I have to I have to add um I have to add a day in seconds to this current time. So now to get the day, so let me create another. Okay, let me write the logic. It is duration.js file. Let me just comment this for now. So let me go to duration.js. So const duration is equals to this be an object. So seconds function that takes in, let's say, value. So return value. So if a value is passed to this function, so we just want to return the value. Minutes function value. So now we're expecting the user to pass in a number. So if the user pass 5 to this particular minutes function, if the user pass 5, so we want to convert that 5 to seconds. Now what I mean by that is, so let me go back to my timelock.js. Before writing these minutes, let me quickly export export duration. So let me go to my timelock test. Then so let me just repeat this duration, then duration. Okay, so now what I want to do is starting time. So I want the syntax to be like now plus duration dot, since I want the starting time to be a day from now, so that will be duration dot is 1. So this is what I want to do. So this will return 1 day in second, the value of 1 day in second. Then the return value will be added to now the current time in seconds. So that will be our starting time, since Solidity only takes in starting time, and I want my closing time to be the starting time plus duration dot days. So which means I want the closing time to be 3 days after the starting time. So this is what I want to achieve now. So I'll need to go back to my duration .js file, then write the logic. So let me duration. So this let me start with a minute. Function value. So in this case, the user will pass in the time. The value the user will pass will be in minutes. It's like the user passing let me just use this duration dot minutes 3. Now if the user pass in 3 here, the user is expecting this function to calculate this 3, to convert these 3 minutes to second. So that's what we want to achieve now. You want to try to convert the value the user pass. You want to try to convert it to second, to the equivalent value in second. So now what I'll need to do is I need to convert this value to seconds. So that would be, let's say if the user pass 5. So to convert 5 minutes to second, so that would be 5 minutes times 60. So this will return 5 minutes in seconds. So now so now to do this, I just have to return value. That's 5 times this duration dot seconds, then I'll pass 60. This is what I mean. This dot duration, then pass 60. This duration dot, I'm sorry, duration dot seconds, then let me pass 60. Now what is happening here is this dot seconds, this will give me 60 seconds. Then I'm multiplying this 60 seconds with the value the user pass. So we are expecting the users to pass in the value in minutes when user calls this minutes function. So now this line 7 will return the value in second, the minutes in second. So that's it. So once you write the logic so value. So in this case, we expect the user to pass in time in hour. So let's say the user passing 5. So that's what let me put a comma here. So time block test. So now if the user pass 3 here, it means the user is trying to convert these 3 hours to seconds. So now let's write the logic here. So the user is trying to convert 3 hours to seconds. So now to convert 3 hours to seconds, so I will need to multiply 3 hours by 60 times 60. So 60 times 60, 60 times 3 will return a value in minutes. Then if we multiply it by 60 again, so it will give us the time in second. But instead of multiplying it by 60 twice, we can do this: return value times this dot minute minutes, which is 60. Then 60 minutes make 1 hour. 60 minutes make 1 hour. So this value times this will return the conversion in seconds. Yeah, so that's what we want to do. Okay. Or let me reiterate this. This is a minute 60 will return what is a year, because I'm just trying to call this minutes version of our duration of this duration variable. So it will return, it will go to the minutes key, then it will check the portion of the minutes key, then it will return the value times this the seconds times 60. So this is what is going to be returned. So now this dot minutes dot 60 is just like multiplying 60 by 60 itself. So that's it. All right. So the next thing we want to do is we want to write the conversion in this. So that would be function value. So 3 days in seconds. Let's just put this now in seconds. Okay. Now since we know that 24 hours make 1 day, 24 hours make 1 day. So 1 day, 24 hours times okay. Let me write this: return value times this dot hours. So 24 hours. Now we know that the value that will be returned by this hours portion will be in second, and we know that 24 hours make 1 day. So now this value in second times value will return the values are passed. So return the equivalent time in second. So that's it. So now let me write let me put a comma here. Can put a comma. Weeks function value. So now we know that 7 days make 1 week. 7 days make 1 week. Make 1 week. Okay. So and we know that we can convert these 7 days to seconds by calling this days function, then passing 7 to it. So with that, we can easily convert these weeks to seconds. So this is what I mean. Return value times this the days 7. So this the 7 days is equivalent to 1 week. So it's just like we are multiplying 1 week by what is our passes in here, and the days has already been converted to seconds because of this function here. So now this time here in seconds is multiplied by what is our passing. Like if it's our passing 2 weeks now, so that 2 weeks will be multiplied by a week in seconds, so which we actually evaluates to the total time in second. So that's it. Weeks and years. So function value. So 35 days make 1 year. So and we have a way of converting 35 days to seconds. So you can do this. Return the value times the days to 35 days. So 35 days make 1 year. So now this will return 1 year in seconds, then multiplied by what is that past year. So that's it. So now I need I've exported duration option already. So okay, now let's go back to our time lock test. Okay. Now the next thing we want to do is now we want to call our set timestamp function of the time lock contract. So now to call it, we already have an instance of the contract here, time log. So now I want to call this instance in the body of this test. Now to be able to have access to this instance, I need to change this time log to the time log. This is the time log, so that I'll be able to use this time log contract anywhere in the test. So without doing it like this, I'll be able to have access to it within this the body of this test. So now this the time log is equals to time. So now to deploy it, I want to change this also to this the time log. Okay. Now I want to call the set timestamp function. So this the time log does set timestamp. Set timestamp. Let me just copy this and go back to my test. I paste. So starting time and closing time. Okay, now since I want since I'll be using this starting time and close time multiple times in other test aside from this, so I will just move this up. I'll cut it and I'll paste it here, maybe here. Yeah, so let me paste it here so that I'll be able to use it everywhere in the test. So instead of declaring the variable like this, I'll change it to this dot closing time. So now let me also change this current time. So now this dot now this dot starting time. Okay. All right. So now I just have to refactor it here. So this is dot closing time. Okay. Oh, so let me just read this comment here to clean up the code a little bit. So now let me use the out keyword since this transaction might take a little longer. So okay, so let's run our test and see what is happening. npx add arts test. I think I need to change the group name. So let me just change this. So let's call it Timelock. Timelock. It does. Oh, I spelled these providers wrong. It doesn't have this. So let me go back to current time. So let me change this to provider. Provider. So let me rerun mbs and act test. Right, so it is executing. Cannot read property, get block number of undefined. Let's go back to the current time. Let me delete this since it is globally available. Let me just delete this and run it. nps and add test. Yeah, so it has passed. It set closing time and the ending time. So let's go back to our test. Okay. So now what we want to do now is now we don't actually know who sets this timestamp. We don't know the address that are called this set timestamp function. So what hardhat does under the hood is it uses the first account out of the account it generated. So to check all the accounts, so you can use npx hardhat accounts. So this code will list out all the accounts generated. Okay. So these are the accounts. So now the color of this set timestamp portion is the first account. This first account. So we can check it out by. So let's try to check the color of the set timestamp portion. So let me just say transaction. So I'll wait. Transaction dot wait. So this will return a receipt. Now let me print out the receipt. Now if I print this out, so let me just run the test one more time. Add test. So we are expecting the color to be 0xF39. Okay, I think this is running. It is executing. Let me bring this up. Okay, now as you can see here, from address from 0xF39. 0xF39. So that's the current color of this smart contract. So hardhat automatically choose the post address whenever you didn't specify the address explicitly. So that's it. Okay, so what we want to do next is let's try calling this set timestamp function again with this address, with the same address. So now let's try that out and see what will happen. So let me just copy this. Let me copy this and let me paste it here. So I'll wait this timelock does set timestamp with same address. So now let's see what will happen. So if I run this at test. So we are expecting an error message. This error message, time has already been set because it's going to revert here. Let me go back to our test. So it's already running. She sets. Okay, it's done executing. Yeah, as we can see here, time has already been set. It has reverted. So yeah, which means our code is working. The set timestamp portion is working. Yeah. Now to prevent this from happening, like to prevent this from failing, let's use this function So we are expecting this particular transaction to reject. So we can use dot should reject with revert. I'll explain this in a few moments. I think it is should be rejected with should be rejected with revert. For us to make use of this should and be, this should and be, so we need to write this up here. So let me close the terminal. So we need to write this up. Const should is equals to require jai dot should. So you have to write this. Then you have to use jai dot use require jai as promised. So we have to make sure that this share as promised is already installed on our project. So to check it, we can go to package.json. So you have seen it here. The jai as promised has been installed. And if you haven't installed it, you can use control slash yarn add jai as promised. So that's the code to install it on your system. So the next thing we want to do is I want to remove this jai from the here. So let me create jai variable here, require jai. So now this should would enable us to use this should, and this b comes from the jai as promised library. So now let's run our test and see what will happen. nps add test. So we are expecting this to pass now because we know that this particular transaction will reject. So let's see what will happen. Still loading. Yeah, it has passed. So which means if the same user tries to set the timestamp more than once, the contract will reject the second transaction. So now let's move on. So let me just close this. Let me close this. Okay, so let's test if our smart contract will allow users to store some amount of bits. So now let's write our second test. So it should store it some amount of it, Timelock. So now let's write the logic that will test this. Okay, now so the first thing I want to do is I want to get some users we need to run this particular test. So let me go to the before, to this function in the before function. So now let me create some, let me just format this and let me create some users. So this dot users, let me use users is equals to await ethers dot get signers. Okay, now so let's get the post user. Let me use this dot users and 0, this dot user 2, second user is dot users 1. So this get signers will return a list of different signers, like 15 signers, and if the signers are gotten from the address generated by hardhat. The address are generated when I used the nps hardhat account, nps hardhat account. So the addresses are generated, the users are generated, the signers are generated from the address. So we can test this out if we print console.log this dot user 1 dot address and also download this dot user2 dot address. So now if we run this, we know that the post address is 0xF39 or whatever. So let's just run it and confirm. Yeah, so 0xF39 is the post address and the second address is 0x709. So the signals are generated with these fake addresses. So now if we run the test again, we are expecting this this code here to display this first address and the second one to display the second address. So let's just run it and verify that. So npx add test. It is running. All right. Yeah, 0xF39 and 0x709. 0xF39 and 0x709. So you can also create the third address. User 3 is equal to this dot users 2. So this will return, this dot users 2 will return this third address. Okay. It will generate a signer from this third address. So and that's what we need. So let me just delete this console.log. Then let's go to, let me just clear the terminal. CLS. So okay, so let me delete this line. Now it should store some amount of it in the time log. So let's check this. Now I want to call the store function of the Timelock contract. So I'll use the Timelock instance. So I'll wait this dot Timelock, this Timelock up here, this Timelock. So this does Timelock dot store. Then so we are trying to this. Now if we didn't specify the address, Timelock hardhat will automatically use the post signer of the address, the post signer, this user 1. So that's what Timelock hardhat we use automatically. So value so ethers dot utils dot pass unit. So let's say 2 ether. So what we want to do now is the post user is trying to deposit 2 ether to our Timelock contracts. So yeah, so I think this should be units. So I wait this the Timelock store value. Okay. Now instead of repeating this, because I'm going to convert the amount to ether multiple times, so let me just create a function inside the utils folder. So new file, let me call it ether.js. So now what I just want to do here is async function. So we are expecting a value. So that's why I expected. Ether. So now return ethers.utils.pass units. Yeah, let's convert the value to string and then let's pass. Let's get to return about the user pass to way. Okay, let me just make it a normal function. So now we need to export this so that we will use it in another function. So let me call this ether. So whenever the user passes in any value here, the value will be converted to way. That's what we need. So let's go back to our Timelock test. So now let's import it. So const ether is supposed to require utils header. So now we have our header variable here. So we can now this function. So we can now replace this line with header. Yeah, just like this. So now what we are doing is we want a post user to store 2 ether to our time log. So let's try to grab the balance of user 1. Since we know that the Timelock contract has a mapping that keeps track of the balance of every users that is the Timelock. Now let's check if the balance of this first user is 2 ether. So now to do that, let's call this user 1 balance. The 1 balance. Then let me use await this time log dot balance, because I'm trying to access this mapping and it's public, so it will be available outside of the smart contract. So then I will need to pass the address to this to this balance. So let me go back to the test. So balance, so I need to pass the address of this user 1 of that user 1. So this dot user 1 dot address. So this particular user, the address of this user. So this dot user 1 address. So okay, now I want to check if this user 1 balance will be 2 ether, because the user 1 has already deposited 2 ether into the smart contract. So we're expecting user 1 balance to be 2 ether. So let's just confirm. So expect user 1 balance to equal that 2. Yeah, so let me just convert this to values to string to equal string. So now let's read and check if this test is going to pass. So /nps hardhat test. Okay, is loading. Yeah, it worked. So which means our smart contract is working. The store function and the balance function are working. So let me just clear this. So let me close the panel. Now what I want to do is I want user to also deposit, to also store into the time log. So I'll wait this time log dot store value, let's say ether, 4 ethers. So now because I want this transaction to be performed by user 2, so I need to specify that this should be called by user 2. So to do that, I'll use the connect function. Connect. Then so let me pass user 2 here. So that's it. So I want user 2 to store 4 ether into the Timelock contract. So now let's check user 2 balance. User 2 balance. Just await this Timelock dot balance this dot user 2 dot address. Okay, so let me just copy this line and paste it. Control C. Then let me paste it here. So we're expecting user 2 balance to equal user 2 balance to equal 4 ether. So let's check if it pass. So let's use it should log the time log when current time, when our current time gets to starting time. This is the starting time. But let me just use starting time. Okay, let me look like this. So asynchronous function. So let me just open the. So now let me format my code. Okay. All right. So now what I want to do is I want to try. I want user one to try to withdraw from the Timelock contract when we've not the starting time has not elapsed. So I want user one to try to withdraw. Let's check if it's going to withdraw. If it's going to withdraw successfully. So I'll wait this the Timelock dot, because I want to use user one, so I don't need to use connect dot user one. I can leave it like this, but add that we generally use user one by then specify the address, by then specify the user. So this the Timelock dot withdraw. So out of the 2 ether, after the 2 ether stored by user one, so let me try to withdraw only one. So withdraw one, because the withdraw function takes in an argument amount in weight. So let's go back to our test. So that's the amount I pass here, 1 ether. So this the time node will withdraw 1 ether. So now we know that this transaction here is going to fulfill because our current time is not yet hasn't reached the starting time, so we're expecting it to fulfill. So let's use dot should be fulfilled. So now let's test it. So control slash nps add test. So user one is trying to withdraw 1 ether out of the 2 ether stored in the time lock when starting time has not yet we've not reached the starting time. Okay, should load the time lock when current time assertion error expected promise to be fulfilled, but it was rejected with VM exception while processing. So I think something is wrong somewhere. So let's try to find the error. Okay, let's check the time the smart contract and check what is happening. Let me go to the smart contract and check if we have any problem with our withdraw function. So is a time present and oh, I think I've seen what the problem is. So we are trying to now this condition we always will evaluate to false because this should be or instead of and. Should be or, because we want the user to be only able to withdraw when the current time, the block dot timestamp, that's the current time, lesser than user starting time, or it can be and, because block the timestamp can be user dot, it can be lesser than start time and at the same time lesser than the closing time. It's not possible, so it should be or, not and. I'm sorry for that. So now let me try to run this again and see if it would work. That's the purpose of writing tests, so we're going to know where the problem is before deploying it to the testnet or mainnet. So npx add test. Okay, it is running. We're expecting this to be fulfilled because the current time is not yet up to the starting time. So okay, now it has compiled our Solidity file. So yeah, it has passed. So that's the problem. Okay, now the next thing we want to do is let's check the balance of this user one and see if 1 ether has been deducted from the 2 ether the user stored. So let's check user one balance. So await this the time log dot balance of user1 dot address. So we are expecting this user1 balance. Let me convert it to a string to equal eta1 the string. Okay, so now we know that when user1 stored called this store function, user1 passes 2 ether there. So user1 deposits 2 ether to the time log. So here user1 has withdrawn 1 ether. So we are expecting the balance of user1 to be 1 ether. So now let's run our test and see if it's working as we expect. So npx hardhat test is running. Yeah, it has passed. Okay, so which means our balance mapping as it is updating, and that's what we want. Now we want to fast forward time to the starting time. Yeah, that's what we want to do now. We want our current time to be after the start time. So let's create a portion that will enable us increase our time, like to fast forward the time to the future. So now let me go to the utils file. So let me create another file. Let me call this increase let me just call it increase time to your JS. So let me go back to okay. So now what we want to do here is okay, let's just let's create the function increase time to, so expecting user to pass in the time. So let me export this function increase time to. Okay, so the next thing is, so let's get the current time. So now I will need to import the current time. So const current time is also require current time. Since we are exporting from the same folder, so current time. Let me give it a space here. So const now is equal to await current time. So this will return the present time, like current time right now. So that's the time it will return. Okay. So now let's check if target is lesser than now. If target is lesser than now. Now if the target is lesser than now, that means you are trying to go back in time. So which is not possible. We are trying to go back in time. So let's throw an error if the target is lesser than now. So throw error. So let's say cannot increase current time now, cannot increase current time to a moment in the past. So now that's what we want if the target is lesser than now, we should throw an error. Now after this, so now let's get the difference between the current time and the target. So difference is equals to now I mean target minus now. So now we want to increase the time by this difference. So if this is the current time, we want to increase the time by this value in seconds, this particular time in seconds. So let's create a function increase time by difference. So let me increase this increase time by up. Let me just create it above the increase time to function. So increase function increase time by, let me pass difference, and let me open this. So now to increase the time, this is the code. I'll do that. Network dot provider dot send EVM increase time, then the difference. So that's all. Now this will only work with a local blockchain because we are using hardhat, generated blockchain by hardhat, so it will work. It won't work on a test net. So increase time by, so it is going to increase the time by the time you pass to the argument. So let me put here increase time by difference. Okay, so increase time by, so we need to make this await to be an await function. So let me just put it inside the variable. Let me just use results. Let me delete this. So return results. I think we are done with the increase time to function. So let's go back to our time lock test. Okay, so let's import the increase time to function. So const increase time to require slash this increase time to. Now let's make use of it in our test. So we want to increase the time, like we want to fast forward the time to increase time to starting time plus 1 second plus 1 second. So we know that if the starting time is if the starting time has passed by 1 second, so the smart contract should be locked by now. So now let's try to withdraw from the smart contract again and check what will happen. So I'll wait this dot timelock dot withdraw user1. So now this user1 is trying to withdraw when the time time is already after the starting time. So we're expecting this particular transaction to reject, so should be rejected with revert. Okay, so that's what we want to like check. So we want to check if after a certain time the user, we want to make sure that the user won't be able to withdraw after a certain time. So the start time has passed by 1 second. So now let's check if this transaction is going to be rejected. So let's open our terminal. So nps add test. Okay, it is. This time takes a while to load. So let me just close this. Let me close this. Oh, so this does. Oh, I made a mistake with my withdraw. So let me just change this to withdraw. So let's run this again. See that as well. Yeah. So npx add test. Okay. Okay. Expected promise to be returned with an error, including the reverts, but it was fulfilled. Oh, we ran into an error. So okay, I think okay, let's put await here. This should be await because it will take a little time to for this transaction to be executed. So let's put await here. Now let's try to run it again and test. So she will be rejected because we are already, the time is already after a certain time. So we fast forwarded the time to a time after a certain time. So yeah, it has passed. So which means our Timelock contract is locking. So now the next thing we want to do is let's try to increase the time after the closing time. So increase time to this dot closing time plus 1. So which means we are trying to go up, we are trying to make the time to be after the closing time. So when the time is after the closing time, the user will be able to withdraw again. The user won't be able to withdraw only when the time is within the starting time and the closing time. Now let's check if this user won't be able to withdraw. So I'll wait this the time log withdraw one balance of the user one dot should be fulfilled because we are now, the time is now after the closing time to be fulfilled. So this the time that I'll withdraw one should be fulfilled. Okay, now let's run this and check if it's going to be fulfilled. Test. Oh. Yeah, it has passed. So let's check the balance of user one at this point, because we know that user one has already withdrawn the remaining 1 Ether. So now we're expecting user one balance to be 0 after this transaction. So we're expecting user one balance to be 0. So let's just check const user one balance. I think I used a variable. Okay, let me just use new user one balance. New user one balance equals to. So let me just copy. Let me copy this. So let me copy this. Please and paste it here. Okay. Now let's check user two balance also. Now user two balance. This user two stored 4 Ether into the Timelock contract. Yeah. Yeah. This is the code. So user two stored 4 Ether to the Timelock. So we're expecting user two's balance to remain to still be 4 because user two didn't tamper with didn't withdraw at all from this Timelock. So we're expecting user two balance to be 4. The balance is that user two address. So we expect new user one balance to equal 0 and new user two balance string user two balance to string to equal 4. So now let's check npx hardhat test. The Timelock there's an error. Oh, so it's supposed to be 4 week, so Ether 4. Yeah, so this is what it's supposed to be. So let me just take it again to string. It's supposed to be in a string. So let's just check. I know this. Okay, yeah, it didn't really matter. So let me just take remove the string. Okay, now so it means that our Timelock contract is locking, and also the withdraw portion is working perfectly. If all the functionalities is working, because we've tested the withdraw function, tested the store function, and also the timestamp function. So now our Timelock contract is working as we expect. So yeah, that's it. So I think we had done. All right, guys. So we are done with our smart contract, and we've also written the test. And we've we've made sure that all the functionalities of the smart contract is working fine. So guys, if you learn all of things from this video, so don't forget to subscribe, and you can turn on the notification bell so that you will get notified when I drop the next video. So you can also share this video to your friends and family who are also interested in smart contract development. So thank you guys. Have a great day. Bye.